All right, so we're going to be reviewing School Interface 2 this morning. Again, this is just a continuation of School Interface 1, which we started last week. So let's kind of read the README and maybe get some starter code from a student solution. So, all right, so release 0, we're going to be adding a menu. So this will actually be our user interface where the user can actually control what they're doing with your application, or if they want to list students, if they want to view some data, they should have that control. So this is how your user will interact with the program that we started writing with School Interface 1. All right, so we're going to create a simple menu that's going to run in the terminal. The user should be able to input a value, and then based on their value, we should respond appropriately with our application. So again, we're just going to be implementing parts of this menu. So part 1 is listing all students. Part 2 is reading, or action 2 is viewing a single student. So if they enter 2, they should be able to enter a student ID and then see the relevant information for that particular student. We talked about the str method, the dunder string method. You guys hopefully understand why we want that. And then I think that's all we're doing for today. So it looks like we're implementing half of this menu where we have list all students, view all students, and we're going to get to add and remove probably for School Interface 3. So that functionality will not be added, but we do have that menu option that we should be adding. All right. I think I mentioned I'm going to see a student solution. So let's pick out a student solution. Anyone want to volunteer from this list? I know I kind of just usually pick, but I know we've seen some of your guys' solutions. So let's go with Jonathan Ray. Hopefully you're fine with me picking your solution. So I'm going to go to Jonathan's GitHub, copy that, and then looks like I don't have all my windows open.
Ankur, are you hotkeying all your windows?
I am not. I'm not sure what that entails, actually.
Is when you program one of your keys just to open a specific window on your
No,
keyboard.
I didn't even realize that's a thing, but maybe I should set it up. Sorry, I had to reboot my machine because my computer wasn't charging. All right, so we are git cloning, and then this will be Jonathan's solution. For School Interface 2, we'll just take a look at it. Maybe have Jonathan talk about some parts of this code if he's up for that, and then yeah, we'll go from there. So I want to cd into School Interface 2 and code that up. All right. It's been a little slow this morning, but it's Monday. This computers need a day to wake up to. All right, so here is School Interface 2. Let's take a look at the runner. So the runner here is going to instantiate a school object from the school class. And then we're going to have basically what seems like an infinite loop, right? We just have while true, but the thing that's going to allow us to quit is this break statement. All right, so it looks like Jonathan's coded up a menu here, just a simple input with a prompt. And then he's coded up 2 of those inputs to kind of react to. Okay, cool. Let's take a look at, just kind of review what we're working with. So we have our student class. So it looks like Jonathan has used inheritance, which is what we obviously were recommending. Class method. All right, then we also have a staff class that's very similar to the student class. It looks like there's no str method for our staff class because we're not printing out staff data. So the student class has a str method that should be used when we print out the student right here. That is what's going to actually allow us to see some student details. Okay, anything else that we need to cover here? Let's see. So go README here. So we had menu created. We had implementation listing all students. So let's take a look at list all students. You can see that list all students. It's a method. Again, this is an instance method on the school class. So let's look at the school class. And then we have list students. It looks like we start with a new line, just to get some nice spacing. We have our students already loaded in. That should have been done in our init method. So again, we talked about the init method. this is where you want to do stuff that you want to guarantee is going to happen, right? So we're guaranteeing that all the students and staff are going to be loaded when the school gets created. There's no disconnect. Again, this is a design decision, but there's trade-offs here, right? We're loading all the staff, but currently, as our application stands, we're not using that staff data right now. So again, that's a trade-off. We're doing extra work ahead of time, and we're not actually needing to do extra work. But the benefit of this is, again, whenever we do need to use staff, anyone that's using this interface, as in the school class, they don't have to call a method that says, all right, load all staff for me first, and then I can use it. They kind of get the benefit of saying, all right, everything should be initialized already, and I could just use the data as I need it. I don't need to worry about loading more data or doing anything extra. Does that make sense? So again, always comes down to design decisions. If this staff, for a reason, if the staff method of loading all data had a considerable hit on our performance or our, I guess, time execution, let's say there's 100 million staff that we had to load in, that at that point, it might be wise to not do this all the time and only load the staff only when you need the staff data. And what I mean by that is, let's say we need something from the staff, initialize the staff once, and then have it available for the rest of the time that the school class exists. Right, but as we have it right now, this isn't a considerable hit and we're not worried about performance too much. So doing this in a init method is totally fine for our needs. Okay, so going back to the list students method, we have all of our students guaranteed to be loaded because that's on the init method. Looks like Jonathan is using an enumerate method. That kind of just is convenient for us. It prints out both the index and the value of whatever you're iterating over. So in this case, the value is going to be the student record. And it looks like we're just listing them out by number. So we're going to get student name and student ID. I guess in this case, I would probably recommend using the str method. So here we have age and student ID listed here. Again, you don't have to, but again, usually whatever you're going to print out should be tied again into the str method. This goes back to us talking about the single responsibility mechanism or the principle of that. You should only have one place kind of doing the work for you or having the logic for you. But again, it just depends what you want to print out. So in the school example, looks like we're printing out name and ID, because that's probably what we asked for. What was that? Place one, view a single student. Not sure if they said specifically what to print out, but again, they're using
zero.
Sorry, we're using list students. Sorry, thanks. Yeah, so list students again. They didn't tell us what to print out. I don't think so. Let's review that. Yeah, I guess they don't tell us how to implement list students, but I guess again, this is not wrong. It's a design choice, but I usually would probably just rely on the str method. So instead of doing this, I probably just do what am I doing? Student, and that should channel the str method. But let's keep it as is and maybe make that change after that. So let's actually run this program. It looks like it's coded up correctly. So great job, Jonathan. Let's actually test it out. So I'm going to run the runner, Python runner. Okay. Okay, looks like we got an error. Totally fine. No one's a perfect coder. I've never met anyone that's always, had something coded up that always worked. But let's see. I don't know if I screwed anything up here. So init method got an unexpected keyword. So again, always get in the habit of working with error statements. I know early on, especially for early developers, it's easy to kind of just panic like, hey, this broke, can you help me out? That's not what we want you to be doing for two reasons. One, if everyone did that, our resources would be, sapped dry. But also, as a software developer, you got to be able to understand how to fix your own code because you're the one writing your code. You know your code best. That doesn't mean you always will know how to fix it, but just try your best to kind of understand the error message and then work your way to locate and maybe try to identify what's going on. So looking at this, it says type init got unexpected keyword argument school ID. And then if you look more in the error message, it should point you to where that's happening. So looking here, it says person line 21. Load all. So let's kind of just follow the tracks here. So I go to person, got load all, and it looks like it was calling class row. So class row here is initializing a student object. So we can just kind of working our way backward. We have line 10 and all students. So if we go to students, we're just calling this method line 10. John, you have, yeah, go for it. You're the author of this code, so I'll let you chat about it.
I guess, first of all, disclaimer, no one looked too closely at this. It's not that great. Honestly, I have a question.
Yeah.
I'm not really sure when to use like regular methods versus class methods versus static methods. For this one, I definitely leaned heavily on your solution for the first part video. And then also like the expected starting place for the next challenge. I think what might be happening right now though is I'm not sure if the student file, the student CSV file, it's got school ID at the top, and I think it should be student ID.
Yep.
Because I changed it to student ID as well.
Okay.
Just like in your solution video.
Gotcha. Yeah, actually, yeah, that might be the source of our error here. So let's actually run it again. Here we go. Yeah, good job identifying that. So yeah, if you remember, I renamed my my record to student ID here just because I thought it was more accurate. Usually we don't want to be manipulating data, so that's something I did, I guess, kind of a little aggressively. But yeah, I mean, totally fine if you want to use student ID here. Just make sure your code and your files are synced. But yeah, it's good that Jonathan mentioned that. I forgot about that change that we had made for school interface 1. But cool, that seems to have fixed it. So we are indeed running. Looks like there's a false alarm there. But yeah, so again, we have this menu here. And again, if we look at our runner file, this menu should run basically indefinitely until the user enters 5, which is the option to quit, right? So if I enter, what happens if I enter, a bogus number? That's something we want to cover. So if I hit 7, notice it loops again. And now the question is, why does it loop again? Like, what if I enter, donuts as my input? Notice we loop again. Well, the reason is because we have our condition as true, and then we get an input. This input actually halts execution and waits for the user to actually enter something. We get a directory value back, and then the directory value checks if it hits any of these conditions. If it doesn't, it actually just kind of goes back. Like if it doesn't hit 1, 2, or 5, it just kind of skip over this entire block and go to the next loop, because again, we're looping infinitely, basically, and then ask for the input again. So again, that is appropriate design, as in if they're not entering something, just show them menu again. Maybe additional step, again, not required, but this is stuff that we would want you to maybe, you guys to maybe just think about on your own. If you're creating a real application, what do you actually want the application to do? So like, couldn't hurt to like maybe check if it doesn't hit any of these cases, maybe display an error message saying, hey, invalid input, please enter a value between 1 and 5 or something, just some prompts for the user. Again, not required, just, definitely nice to make your application as user-friendly as possible. But yeah, in this case, it looks like I'm not entering a good input, so I'm just getting the menu back, which kind of tells me I should pick a legit value. So let's do number 1, option 1, which is list all students. I'm going to enter a 1 here. And okay, so we got results here. We got Lisa. We're seeing the name and the student ID. And the reason we're seeing that is because looking at Jonathan's list all students methods, he chose to print out name and student ID. Again, the change that I was thinking about, again, just for my preferences, I would generally rely on the str method. So I'd probably just list out student like this. Let's see if I did that, if that would, oops, I need to quit this application. If you guys haven't figured it out already, the way you can kind of drop out of application, if you hit Control-C, that's like a terminal way just to abort whatever application you're in. Usually Control-C will work. Occasionally you got to hit Control-D. I'm not sure why some application, I think if you're in the Python shell, Control-D works, but not Control-C. Again, I'm not sure why, but one of those two should get you out of the application that you're running if you need to. Very useful for if you run into an infinite loop in your application and just want to abort. Control-C should be your ticket out of that. Okay, so let's run this again. Python. So again, I made a change to how we're printing this out. Let's see if this impacts it or if I broke it. School. Oops, runner. I want to run the runner. All right, I want to list all students. All right, so notice we got student ID here. Oh, sorry, I didn't print it out. Yeah, so notice our output here is a little different. And the question is, well, why is it different now? Actually, it looks kind of better, more organized here. That's all coming from Jonathan's str method here. So he's got, this separator, this new line, he's listing out age, ID, and the name in uppercase. So again, I'm relying on the str method, just that's a central place where I know if I need to print out something, I'm just gonna have the str method handle that. But either way, it looks like we accomplished our task. So I'm gonna restore Jonathan's solution where he had name and student ID. That's great. Okay, let's go to option 2. So our menu is still running. Let's try to view a student by student ID. I'm gonna hit option 2. All right, let's enter a student ID, and I don't have these memorized. Let's view details on Slater. So Slater ID is 12335. All right, so if I hit, well, what if let's do the easy case. 1 3, what was it? 2 2 3 3. All right, I have a terrible memory. It was 1 2 3 3 5. Okay, did I do that correctly? Okay, so notice I entered ID for Slater, but it looks like we printed out Jesse. So we might have to do some debugging here, which is totally great. I love debugging. So let's go to
Ankur, it's the line break. It's printing. You entered Jesse's information.
Sorry. Thank you guys. Yeah. So this is Jesse information. Sorry. I shouldn't have doubted John's code. But yeah, Slater's ID is down here. So let's actually clean that up.
Please doubt away.
What was that?
I was just saying, no, you should doubt my code.
No. I think you have
that line's probably not in a great spot.
Yeah, I'm just going to add a new line here. So maybe that will make it a little easier. Oops, Control C. Let's get back in it, clear that, run the runner, view a student. Oops, whatever. We'll view Jesse's for now. And then I want to view all students. So let's see how our output looks now. Did I screw that up? No, okay, so we're back to this format. So Slater's ID is 12645. So let's view Slater's details, 12645. All right, so notice we get Slater output. So, yep, working correctly. That functionality seems to be good. Let's take a look at the method just to see what's going on here. So find student by ID, as you might expect, great name, because that specifies how we're going to find the student. We pass in a student ID. We get that from our user input. So let's kind of backtrack here. So this is our option 2, where we ask the user of our application to enter an ID. In that case, we get the ID from the user, call the method on the school instance, and then get back a student, and then print out that student. And this time we are using the str method, which is good. You don't have to actually surround your object with str. I know that makes it more explicit, but print will automatically kind of do that for you. So the print function is going to expect something. Oops. It's going to call the str method on the student, not directly, but it's going to convert whatever you're passing to a string if it can. So that's just optional. I'll generally say you don't have to wrap your object in an str. So that's just an extra step for your application to actually convert it to a string before doing anything else. Okay, so that looks like it's working, but I did have a question in the back of my mind. So let's actually try something. So I'm gonna bring up my terminal and let's try to find another student by ID. But this time I'm just gonna enter some, made up ID. So let's enter 99 or 9934, whatever. This ID should not exist because if it does, that's really random chance. Hit enter. We get a none back. That's fine. I would, generally want to prefer to see something a little more informative because this none, again, it's just the data type. The reason we're returning none, if we look at John's code. So here we are searching by student ID. And then when we find a student that matches, we return the students. However, I don't think we've fully handled the case of, well, what if we never find that student in our student list, right? So here I'd probably, return something saying student not found. Again, just to be a little more user-friendly. Maybe a more aggressive way that we could do this is maybe raising an exception. Raise an exception, like student not found. if the syntax is correct, but so we haven't talked about the using try except in Python. That was a topic we were going to cover in week 1. We'll cover that at some point, but just understand that you can raise an exceptions, and that's kind of just like showing something went wrong, but we're going to handle it versus kind of letting your application crash. But returning a string that says student not found, that I think should be fine. So if we did that now, we should see that message here. Whatever. So if I go to 2, and there's some bogus inputs. Yep, student not found. Great. That tells me kind of what went wrong. Maybe enter a correct ID. Cool. All right, but yeah, the functionality seems to be great here. One thing I want to mention, just because I've seen it in the past, just maybe maybe prepare you for the assessment. One thing I've seen before is returning too early from a for loop. What I mean by that is, let's try to give a good example here. Usually it's something like, if the first iteration didn't achieve your criteria, sometimes I've seen student code that kind of returns when they shouldn't. What I mean by that is, I'm thinking on the spot here. So student equals ID, return student. I think if I negated this, so if I went like this, again, if you can kind of understand what's the intention here. So again, I've seen this before. I think in apple trees, maybe. But again, the idea here is you need to search the entire student's collection or the list. And I've seen in the past where students like, all right, well, if I'm checking this way and I didn't find a student, well, then the student doesn't exist. That's not necessarily true, because this return is not going to make sure your for loop completes. It's going to return after the first student if it wasn't found. So let's say else return student. So now, again, this might seem like, sure, this is going to return what I need, but no, it's only going to investigate your first student and return on that. So if your first student happens to be the student you need to find, then I guess let's swap these, because maybe that makes my case a little better. So this is what John had earlier. He had this condition. I added this condition just to show, again, some common errors I've seen with some student solutions in the past, where students are like, all right, I'm going to try to find my student. If I do, great, return it. But if I don't find my student, well, then the student doesn't exist. The problem here is, again, we're going to return on the first student no matter what. And that's not what we want, because we need to search the entire collection here. So usually you don't want to return the negative case, or I guess, your assumption that, we didn't find what we're looking for. You want to do that outside your for loop, not inside. All right. So again, I've seen that often enough that I thought it was worth mentioning. Going back, so yeah, I think that achieves our solution. Let's make sure we can quit our application. So I'm going to hit a 5. Great, we were able to quit. So it looks like this hits all of our to-do list for school interface 2. But I think John brought up a good question, and I think it's worth exploring here. So let's take some time since we have it. I believe the question was, not always sure when to use create an instance method versus a class method versus a static method. And that's something definitely we should focus on. So let me trash my terminal. So right now we have instance methods. These taken in itself. So let me maybe add these in comments. So we have 3 types that we've mentioned. One are instance methods. So instance methods. Does someone want to try to describe what an instance method is? If not, we could definitely cover it together.
I can try.
Good description for it. Go for it, Brandon.
Okay, sure. Yeah, so an instance method, I think that's probably preferred to use for like specific instances of the class. So like if you have a student called like Susie, then it's like methods that Susie would use that kind of interact with like Susie's data. Whereas, if you're just talking about broad students, you might want to go more class method.
Yeah, so as Brandon said, when you have something that's specific to the instance, so in this case, we have a student named Susie, and we want to get like Susie's age, we want to, have update Susie's GPA. It's only specific to that instance, or in this case, to one particular student. So anything that you need to do for one student, that would be an instance method, because it only applies to that instance, hence the name instance method. The little more maybe clouded or unclear item that we haven't done as much are class methods. So class methods, that's a function that doesn't rely on an instance, but instead relies on class information, or let's say class attributes, or class. Okay, so let's actually talk about this. Let's continue maybe our student example. So let me maybe move this to our students class. All right, so again, let's cover instance methods. So let's say we need to update our student GPA. Well, one way we could do it is just directly, let's create a student here. Let's go with Susie, since that was the suggested name. Susie will be a student that we're gonna just create for our usage here. Students, we need to pass in some information. So we'll go, name is Susie. Age will be 16. Role will be student. Not sure about this role parameter, but password will be I love donuts. Okay, so we should be able to create a student instance, I missed the parameter, student ID. So let's say Susie's ID will be 99999. All right, so we create Susie. Now let's say we need to update something from Susie. Well, one way we could do it is just do Susie.password equals I hate green beans. All right, this is one way we could update an instance attribute, right? We do have access to password because that is something that gets created during our init method. Specifically, it's by our person class, but we still have access to it. We can update the password like this. I'm not sure how to quantify this. I would say usually you don't want to do this, but sometimes it makes sense to, because if it's something that you're okay with and you understand the ramifications, totally fine to do it this way. But let's say in my example, we have this password. Well, let's say we actually hash that password. And this is something that actually happens when we get to Django. We'll be talking about this, but most of the time, if not all the time, passwords are never stored as clear text. So, if my password for something was I love donuts, that would not actually be the value you would see if you inspected the database. The database would actually hash it, or basically encrypt it, so that in the event that your database gets hacked, like a user will not be able to find out the password for that account. So in this case, let's say that we actually hash this password. Well, now if we set the password directly, that's not gonna, this is gonna break our system. And this is something that actually happens in Django. So when we get to Django, we will see this in action, where we need to call a specific method. So what I'm saying here, let's kind of make sure you guys understand what I'm saying. Let's say we don't store it as a clear text password. Let's say we actually hash it. So let's say our hashing method, or basically salting method, is going to be code platoon hash. All right. So what we're doing is basically appending something that to the original password. Again, this is not a good method, as in we want to actually encrypt this and do something different. Let's say just, again, this is our hidden secret sauce, where like we always append or prepend with code platoon hash, so that no one knows actually what the original password is. This gets more into data integrity. Again, I'm not an expert in password hashing, but again, the idea here is just to kind of mask the password a little bit. We can maybe jumble the letters here, get a little more advanced. I'm not going to do that. So now the question is, well, what happens if you directly assign it? Well, this is going to break our system, right? Because now when we actually try to get the password, we're going to look for that code platoon hash and try to strip it off. You guys with me here? Have I lost you guys? Sorry. Can someone give me like 2 thumbs up if they're good? I got 1 thumbs up there from Brandon, but yeah. So again, the idea here is this might not be totally safe. So the whole thing I was trying to get at here was we need to create an instance method. So let's actually create one in our person class. We're going to call it def having issues. Let's have these out. So I'm gonna create a new method. Again, I'm creating in my person class because that person is the one managing the password. So I'm gonna create a new method, call it def set password. This will take in self because it's an instance method, and then the password. So new password. Right, and then we're going to do our hashing here. So basically self.password is going to be set to what we set up here. Quick tangent. What's wrong with my design here, or what can be improved with my design here?
Definitely just call that new method that you just wrote when you set self.password and init method.
Yep, James has it. Not sure why I have some grayed out text here. All right, there's something wrong with my tabbing or something, but yes, James nailed it on the head. I'm doing something here on line 9 where I'm initializing my password from the passed in parameter, but then I also have that logic in this method. And then again, this goes back to the single.
Line, is it 19 and 21 just need to be tabbed in, I think.
Good catch. I think you are correct. Yes, you guys are awesome with your error handling skills there. But yeah, thank you very much. So yeah, again, the single responsibility principle, again, we've mentioned it. The whole idea is if you're doing something in your application, it should only be done in one place when possible. Most of the times it should be possible. So in this case, we have logic that's duplicated, which is fine. This is going to work, 100% work. But the problem is now we have this logic separated into multiple places. In this case, 2 places. But again, imagine a large application might have this in 5 places or 10 places. The problem is, well, what if we need to update our hash to be like, include a new word or whatever we're doing, right? A coder, like, especially with large projects, you have multiple people working on it. I might not know that I need to update this in other places, right? I might just assume like this is only the place, that has our hash. So I'll do it here. Now this is going to cause other problems because this place never got updated. Again, the potential for bugs goes up a lot more when you have redundant code, and also reduces, again, your code reusability. So as James said, we definitely should be calling self.setPassword, and then we'll pass in our password there. So now this is centralized. The logic to hash our password is in the setPassword method. All right, so we created an instance method because it's going to be individual to setting that password, right? So let's now, instead of doing this, we should be calling the setPassword method because that's going to do the appropriate thing for us. And then again, this always goes back to, well, how do I know if I need a call method or if I can just get away with, assigning directly? And the answer always is going to be read documentation, fully understand what the code is doing. So I hate green beans with my new password. And then let's print Susie's password. Hopefully she doesn't mind us exposing her password. So if we print, I'm probably gonna need to put this in the runner file because of imports. So sorry for jumping between files. Let me grab that out of here. Let's go back to our runner. I'm going to comment out our menu for now. Let's just create a student instance. From classes.student, import our student class. And then let's see some passwords here. So create Susie. School can stick around, it's not doing anything for us. Then we set a password and then we see it again. All right, so let's do Python runner. All right, notice, oops, I don't even have new lines here. What went wrong here? Oh, I know. Do I know? Person. Yeah, sorry, this is not returning anything. So our set password updates the password, but doesn't return anything. So I was assigning the return value of this function, which is none, to the password before. So this was wrong because this returns none. And that's what we're assigning to our password. That was bad. Let's fix that and run this again. All right, there we go. So the first password is Platoon hash donuts, I love donuts. And the second one is Platoon hash donuts, I hate green beans. All right, so again, the whole idea here is that our set password function is doing something extra. So we shouldn't necessarily manipulate our data outside of our class. That's what methods are for. So this is instance method. Let's talk about class methods now. So kind of lost track where my comments went. Go back in my runner file. Yeah, so class methods now. This is where a function that doesn't rely on a particular instance, but instead relies on some class attributes or class methods. So again, this is something that might be class specific. So let's create a scenario where a class method would make sense. And usually it's because you have class data that is required. So let's go to my person class. Let's create a static or a class level attribute. So in this case, I'm going to create our password salts is going to be code Platoon hash. I think I changed it a bit, but that's fine. All right, so now this is a class level attribute. This exists outside of an instance, as in a person or a student does not need to exist for this value to be relevant. So now that we have this, we have a class level attribute. So I'm gonna update my instance here. So let's do self.our password salt. All right, so again, still an instance attribute because we need to update the instance value. But what if I wanted a method to actually expose the salt? I could use def get password salt. And now a couple questions here. I could do self and do something like return self.our password salt. All right, so let's actually see this and maybe talk about it. So if I
on line 29 back there, you use self and not class.our password salt.
That is
just trying to understand.
That is correct. Yeah, right now I've created an instance method right here. So self is correct because this is an instance method, and we'll talk about that in a sec. So
Okay.
Good thought there though. So if I pass in nothing because it takes no parameters, let's print that out. Salt equals that. Print salt. Again, if you're not familiar with the term salt, it's just used for kind of manipulating passwords a little bit. You guys can read up on it. So we do Python runner. Oops. Python runner. All right, so notice we get our hash back, which is code Platoon hash from the salt. But the question here is, should this be an instance attribute, or sorry, an instance method, right? I created get password salt, it works. I get the correct result, which is code Platoon hash. That is our salt value. Or we should call it salt. So let me change that quickly. I want that to be salt. Okay, so we get the correct results. Great, I'm done, right? This works for me. I'm done. No, we are not done. We always want to be mindful of how can we improve our design, or definitely reflect on our design. So here, the reason this works is because we're calling self.our password, and the way that Python objects work is that first we will search for an our salt instance attribute, and if that doesn't exist, we'll go to the class level attribute. Well, in this case, we want to be using the class level attribute. So if we never want to override it, I would argue that this self should maybe be person. So we always use the salt that's on the person level, and here we probably want to return person also. Person all salt. So if I run this, what happens? So let's do Python runner. Notice we get the correct value again. Are we done? Well, not quite. Because anytime you see this in your code, this should alert you to why you need a class method. Here, I'm passing in self, but notice I'm never using self here. I'm never referring to self. So this is a case where this should be a class method, because each individual instance does not matter in this case. We're saying that our salt always comes from our class, so that we're not going to allow anyone to override it. So in this case, although that it works, this is not meant to be an instance method. I don't need something to exist to see our salt that we're using. So I could turn this into a class method. In Python, we use something called a decorator. So that's that @ symbol, and you got to add in class method. This is a reserved decorator. Now this is saying that this is a class method. By convention, the first parameter should be named CLS, which stands for class. Again, you can name that whatever you want to, but CLS is the preferred way, so please go about that. And we'll use the class here. All right, so this refers to either a student class, if the student class is the one calling it. Yeah, so again, this has nothing to do with an instance. What I mean by that is if I go to my runner file, Susie does not need to exist for me to know what the salt is that we're using. I can simply call print student dot our or get password salt, right? Because this does not rely on a student to exist. That salt exists outside of the student ever existing. All right, so we get the salt up here. Notice that we are still able to call get password salt on an instance. This is, how do I say this? This is passing in Susie, and then how's this even working? Person, yeah. So we're passing in Susie here as an instance, and then calling our password salt. So it happens to work, but again, you shouldn't necessarily be calling class methods. Where did I go? Class methods on instance. So this is coincidentally works because the nature of how we're actually using our value. We can pass in an instance and still get the class level attribute. But this is not always going to work for you. So just be mindful, never call class methods with an instance. It might work, but it's not how you should be using them. So again, this is coincidentally working, but shouldn't work. Any questions on that?
So in this situation, would Susie dot whatever your variable for salt, like if you printed that, would that still work? So you could see that instance variable, not
Sorry,
call.
Could you repeat that, Seth?
So if you go back to your student,
Students, right here.
yep, student.py, go up to the top.
Mhm.
Where was that salt defined
Oh,
at?
it was in our person class, just because
In the person.
Yeah.
So if you did print Susie dot our password salt, would you
Yep.
still be able to return that?
Yes.
And could you modify it through Susie dot our password salt equals?
You could not modify the class level attribute. So if you're asking, well, what if we did Susie, our password salt equals new salt, right? Is this what you're asking? Yeah. So
Yeah.
again, this is a little tricky, but how do I do this? If I do something, again, we're just gonna get the value straight up from Susie. So if I do Susie dot our password salt, I got a lot of code here, so let me try to get rid of some of it. So let's look at these two lines here. All right, here, when we're printing out Susie dot our password salt, what's happening here is that we are looking for our password salt on the instance of Susie, as in Python's looking for it. It's not going to find it because we never created it for Susie. So it's going to actually bubble up to the class level and look for something called our password salt on the class level. In that case, it does find it because the person class, which is a base class for a student, has a value for that or an attribute at the class level. But if we do something like line 12 here, let me highlight that. It may not be super clear, but what we're actually doing is creating a brand new variable only for Susie called our password salt. And yes, that does match the class level attribute. So now we're actually overwriting, again, this is something we talked about during inheritance, we're overwriting the value of our password salt. So if I print out our password salt, it's going to be new salt. But if I still call this instance method, this is not going to be new salt because that's only been updated for the instance, which is Susie. So if we actually see this run, we should print the salt. Let's get rid of that actually. Yeah, let's just do it straight up. So here we're going to print the original salt, which should be code Platoon salt. We're going to update it for the instance only for Susie. So when we print out Susie's our password salt, or even call, we shouldn't call the method, but we'll get new salt. But calling this should be our original value. We've now overridden the class value. If we want to override the class value, we do something like person dot our password. Sure why it's not finding it, because I probably didn't import person. Import person. Okay, so if we want to actually update that original value, we do, I don't know, some salt. All right, this will update the actual value. Now, if you notice, I kind of avoided doing student.our password salt equals blah salt, right? This salts. This would update it on the student class. Notice that the student class does not have a salt value. We don't have an attribute for the salt. So this is going to do the same thing as before, where we're going to create a new class level attribute on the student because that one doesn't exist. It's not going to use the person our salt. That is fine because the way we've implemented, actually, is it fine? Person. I guess yes. In this case, it's fine because we are using CLS here. So get password salt will actually use it off the student. I think I'm getting a little too confusing here, but the whole lesson here is we're using something that's on the class level that doesn't require a student to exist. So that's why a class method was created. Sorry, I kind of get too into weeds there. We're doing weird stuff here. We're calling person directly here, but we're calling class here. That's not what we want. So in this case, the solution, the proper way to do this would actually be to call person.gets password salt, the method. I'm actually thinking of this will even work. Sorry, I'm not going to go down this road, but the last one we want to talk about are static methods. So class methods, again, rely on class attributes or other class methods. The last one, we're not going to use these very often, but you might see it, are called static methods. What are these? This is a function that doesn't rely on any class or instance attributes or methods. The whole purpose of static methods is just to have some helper function or some function that might be related somehow to your class, but doesn't really rely on the data. So the easiest way I could show this, nothing too exciting, I might create a static method. And all the static method is going to do is going to be print message. All right, this will take in no parameters. This is just like any other function. So let's just say do message. And then all this is going to do is return get message, return students are awesome. Actually make this a little better. Papa students are awesome is what I was going for. All right, so this again, very trivial example. But in this case, this does not rely on any data for the class or the instance. But then your question might be, well, why is this in this class originally? Or maybe let's put it into, let's keep here. The reason this is in here is because this relates to this class somehow, right? So let's maybe make this more relevant. Let's just say people are awesome, right? So this is the person class, right? That has attributes, that has methods. You can create people individually, but I've chose to create a static method that still relates to people because I'm returning a message about people. So I'm kind of just housing it within the class, even though it doesn't interact with anything within the class. Does that make sense? I'm not sure if my phrasing or terminology may be the best. Static method, just to review, is something that relates to the idea, but doesn't need to access any of the data within the class or any instance data. So that's why you create static methods, just kind of just housing it within that class because it ties somehow tangentially to your idea of a person or your class idea. Class methods, you create these when you need access to class attributes and other class methods potentially, but you don't need any instance methods or any instance attributes to be accessed when you call this method. So for our get password salt example, this value exists whether a student exists or not. So we can just create a class method to interact with that data. Again, this is a simple example where we're just returning it. If we need to update it or do anything more complex, if our student doesn't need to exist, then class method is your answer. And what I mentioned halfway through that entire discussion is if you find yourself passing in self, but never actually using an instance attribute, so if I'm not using any of this stuff, that's pointing to me that maybe I don't even need an instance attribute if I'm not using anything on the instance. Okay, and then the one we're most familiar with are instance attributes. You don't need any special decorator for it. You just pass in self as the first parameter, and then you pass in any additional parameters you need. Again, this is interacting directly with an instance. So in this case, we're updating a password for a student. And since we're doing that, that student needs to exist, right? We can't update a password for a student that hasn't been created, doesn't exist in the world. So yeah, you're going to be seeing Class methods, probably a little bit more. Static methods, again, kind of rare. Just understand their usage and definitely incorporate them if you see a chance to in your code. Okay, that was kind of a long discussion, but I thought it was worthwhile. Any questions about school interface 2 or class methods, static methods, anything for your understanding of OOP?
Yeah, that helped a bunch. It definitely made me realize I had no idea what I was doing before. In my budget app, I just sort of like sprinkled class method everywhere.
Gotcha.
But so the decorator itself, it doesn't actually like unlock any special abilities or anything. Is it literally just for organization and readability?
This actually does modify how this function operates. So again, there's definitely some mystery and well-deserved mystery around decorators because we've not covered them. They are kind of confusing. It's a Python thing, but this decorator is actually kind of passing this function into another function. Again, that's a whole separate discussion, but this is not just cosmetic. This is actually modifying how this function operates. But yeah,
Okay.
hopefully we'll get some time to talk about decorators. It's probably a good topic, but not.
Would you would you recommend like writing the function first and then determining, based on the parameters that you pass in, how you're going to decorate it, or like vice versa?
Usually I'll go vice versa. I would try to understand what I'm trying to accomplish with this function and then decorate it that way. But I guess the way you mentioned of like coding it up and then realizing, hey, I'm not actually using self or anything that's related to an instance and maybe changing it that way, that'd be totally fine too. However you approach it, but I would probably go the later route of understanding what this method is going to do and then realizing if it needs to deal with instances or not. I guess they could go both ways.
Okay, cool.
Yep.
Thanks for explaining it.
No, yeah, thanks for that question. Any other questions on school interface 2? Okay, so I'm going to stop share. Stop